Okay, class, so here's our example number 15. So as you can see, we have again a series parallel circuit. Okay, and as you can see, we have lots of resistances given here. So in this problem, we are to determine for letter A the equivalent resistance, or which means the total resistance of this circuit. And for letter B, we are to determine the current in each resistor of the following, or of this circuit. Now, if you can observe, class, there are how many resistors in there? So 1, 2, 3, 4, 5, 6, 7. There are 7 resistors in here. By the way, class, this 0.3 ohms is what we call the internal resistance, where it is already included in the battery itself. Okay, but sometimes some batteries do neglect the value of their internal resistance because it's too small. Okay, in this case, it is 0.3 ohms. Okay, so we have to determine the current in each resistor. So since we have 1, 2, 3, 4, 5, 6, 7 currents, okay, so let us name each current based on their values, class. Like for example, for the current for the resistor 0.3, so let's name the current flowing in it as I sub 0.3, while for the current flowing here, let's say I8, and for here, let's say I sub 2. Okay, well, this one, let's say I sub 6. Here, let's say I sub 10. Here, I sub 1. And this is I sub 7. Again, class, it's up to you what representations would you like to use, but in here I want to specify it. Okay, so we have to determine each of that current. Now, in order for us, class, to solve it, okay, so for the total resistance first, we have to simplify our circuit because as you can see, it is complicated. Okay, we will be applying our principles from series as well as parallel to simplify this circuit here. And when you do that, class, when you try to simplify a circuit, so you have to start in the innermost part of the circuit, which is this one. This is the innermost. So as you can see here, the 7 ohms, 1 ohm, and the 10 ohms are in what connection? So since they are end-to-end, or they are in the same path, obviously they are in series. Okay, they are in series, class. So therefore, let's combine. Okay, combine 7 ohms, 1 ohm, and 10 ohms in series. So let's name their combination as RA, class. Okay, now if you could recall, in series, in order for you to get their total or their combination resistance, is you just simply add them. Okay, so therefore R sub A here is 7 ohms plus 1 ohm plus 10 ohms. Okay, and this is 10, 11, 18 ohms. Again, this 18 ohms is just this part right here. Okay, so from here, our circuit will become simplified and looks like this. So this is our 2 ohms. This is our supply, which is 20 volts, 0.3 ohms. We have here 8 ohms. And we have here 6 ohms. Now, like I have said, these 7, 1, and 10 are already combined. So, of course, there will become 1, which is this 18 ohms here. So, we will put it right here. Our R sub A, or that is equivalent to 18 ohms. Okay? Now, if you can observe, 6 ohms and R sub A, 6 ohms and R sub A are in what type of connection? They are in parallel. Okay, so let us combine them. Combine 6 ohms and R sub A in parallel. And let's name their combination as R sub B. Okay, can you see it? I'm sorry. There. So again, R sub B here will represent the combination of 6 ohms and R sub A in parallel. Now, if you could recall, class, in parallel, okay, we have here a general, take note, this is general formula, class, ha? To solve for a parallel is you use this formula. The reciprocal of the sum of the reciprocals of each resistances connected in parallel. So this is the general formula. So if we apply it, we are trying to solve for R sub B. So our first resistance is 6 ohms. So get the reciprocal of that. And then get also the reciprocal of our second resistor, which is 18. And then raise it to -1 to get the reciprocal. There. So using, class, your calculator here. So we have 6 raised to -1 plus 18 raised to -1, and then raise it again to -1. Can you follow? And that is 9/2 or 4.5. So 4.5 ohms. Okay? So this is the combination already of this parallel here. So what will happen is our circuit will become like this. This is already 2 ohms. This is our voltage source, 20 volt, 0.3 ohms. We have here 8 ohms. And since at this part here, we have combined the 6 and RA, so this is already our R sub B, or the combination earlier. Okay? So as you can see, class, it is already simplified, which becomes a series circuit, which is easy for us to solve, right? So in order for us, class, to solve for the total resistance, if you can observe, 2 ohms, R sub B, 8 ohms, and 0.3 ohms are in what connection? So since they are on the same path, so obviously they are in series. So therefore, combine 2 ohms, 0.3 ohms, R sub B, and 8 ohms, 1, 2, 3, 4, in series. And this will be our total resistance. Okay? So in series, all we have to do is add them. So 2 ohms, 0.3 ohms, R sub B here is 4.5, and 8 ohms. So let's check 2, 0.3, 8, and 4. Okay. So using your calculator, we have 2 plus 0.3 plus 4.5 plus 8. 2.3, 4.5, and 8. Okay. We have 14.8. Okay, 14.8 ohms. And this is, class, already our answer for letter A. Okay, how about for the current in each resistors? Okay, so before we do that, class, so let us first determine the direction of the currents in our circuit. Okay, so as you can see here, our source or our battery is having here a negative terminal, and this one is positive terminal. Now, if you could recall, the direction of the current, or the conventional direction of the current, is from positive to negative, which means that the direction is like that, from positive going to the negative. So which means that this current here will be our I.3, or the current flowing in your 0.3. Okay, so in here, in the 8 ohms, this will be the current. And as you can see, there's a junction here, or a node. So at this point, what will happen is the current will be distributed, right? Based from our what do you call this? Based on our parallel circuit, so the current will be distributed if there's a branch in there. Okay? So what will happen is, so from here, so this will go in there to the 6 ohms, and the other one will go here. Okay? Or simply, if you look here, class, at this point, okay, so we have here current flowing and then going there and going here. Can you follow? Now Now class, observe that this 8 ohms, okay, 8 ohms, 0.3 ohms, and 2 ohms are on the same path. Can you notice that? They are on the same path, oh, which means that the current flowing in 0.3 ohms and in 8 ohms and in 2 ohms are equal or just the same. Okay, so for I sub 0.3, I8, and I sub 2, they will be equal. Okay, can I erase this class? Can I erase this? I will erase this. This one. I sub 0.3 equals I sub 8, I sub 2. Okay, they are equal. So how are we going to solve for it? Now take note that the current flowing in this part is the one from the source, which means that is our total current. Can you follow, class? And if you could recall, in our Ohm's law, current can be solved by dividing voltage by resistance. So since we are trying to solve for the total current, so simply put that one. Okay? So total current, so of course you have to use the total voltage and the total resistance or the equivalent resistance. By the way, how much is our resistance earlier? 14.8, no? Was it 14.8? Yeah, it is 14.8. That's our R sub T. R sub T is 14.8 there. So in order for a class to solve for this, okay, so we'll simply use the 20 volts and then divide it by the total resistance, which is 14.8 ohms. And that will be our total current, which is, using your calculator, there, you see it? That is 50 over 37. 50 over 37. You have the choice, class, if you want to write the whole decimal, but as for me, I want it to be more accurate, so I'll just copy the whole fraction. So like you said, this total current is just equal to the current flowing in the 2 ohms, in the 8 ohms, and 0.2. So therefore, we have already solved for 0.3, 8, and 0.2. So we still have the current here. We have still 4 currents. Now, how are we going to solve for the current flowing in the 6 ohms? How are we going to solve that? Now, recall, class, that it is not the same as 20 volts. Why? If you could recall, in a series, what happens to the voltage? The voltage is dropping in each resistances. There's what we call voltage drops in each resistances. So as you can see here, 20 volts, okay, it is in series with 0.3, 8 ohms, and 2 ohms. So that means that there will be voltage drop in the 2 ohms, in the 0.3 ohms, and in the 8 ohms. Okay? So how are we going to solve for the voltage drop? If you could recall, using the Ohm's law, voltage is simply I times. So using our voltage, which is V equals I times R. So to determine the voltage drop at, so solving for voltage drop at 0.3 ohms. So simply, V is, the current flowing in 0.3 is 50 over 37 times, you have here the resistance, which is 3.3 ohms. So therefore, you'll have 50 over 37 over 0.3 there. And you'll have 15 over 37. 15 over 37. This is volts already, class. Okay? While for the voltage drop across your 8 ohms, so V is equal to, the current is the same, 50 over 37 times your 8 ohms. That is, okay, so the value is 50 over 37 times 8. Okay, so we have 400 over 37 volts. And for the 2 ohms, So voltage drop at 2 ohms. So we have the same current, 50 over 37, 2 ohms. So you'll have 50 over 37. I'm sorry, 50 over 37 over 2. There. We'll have 100 over 37. And this is volts. Okay? So, what are we going to do, class, with this voltage drops? So, we will subtract it from our source, which is 20 volts. Okay? And that value will be the voltage left that will supply here in our 6 volts. So, can I erase this part, class? Let me erase this one. Okay. So, again, this voltage drop will be subtracted from our 20 volts. So, let's name that the voltage at this point is, let's say, V sub 1. Okay? So, to solve for V sub 1, so simply subtract from the source the voltage drop here. So, we have 15 over 37 minus 400 over 37 minus 100 over 37. Okay? So, therefore, the voltage left, it will be supplied to the 6 ohms, will be 20 minus 15 over 37 minus 400 over 37 minus 100 over 37. Correct? And you'll have 225 over 37 volts. Okay? That's the voltage here. So, in order for us, class, to solve for the current flowing in the 6 ohms, so we will still use the Ohm's law. Okay? Can I erase this part, class? Kindly screenshot if you haven't screenshot. So, I will erase this. So, to solve for I sub 6, or the current flowing in 6 ohms, so you'll use V sub 1 for our voltage supplied and the resistance of 6 ohms, which is 6 ohms. Okay? So, substituting, class, our V sub 1 is 225 over 37 volts. There. So, you'll have how much? 225 over 37 over 6. There. 75 over 74. There. 75 over 74. Okay? There. 75 over 74. By the way, how much is our current earlier? Let's take a copy, class, ha? Kasi we will use it later. So, I'll just put it here. I sub T is 50 over 37. And then, this I sub 6 is 75 over 74 amperes. Okay? Now, class, how about for the current flowing at, so okay na to. Okay? How about the current flowing in 10 ohms, 1 ohm, and 7 ohms? How are we going to solve it? Now, if we check here, or if we refer here, so this current is the one flowing in these 3 resistances, because as you can see, class, they are in series, right? So, if they are in series, which means they have the same current flowing in them. So, let us name this current here as I sub A. Okay, which is the one that flows here in our 3 resistances. Now, earlier, we have already solved for the total resistance of these resistances, which is R sub A. Okay? Now, the question is, what will be the voltage across this R sub A? Now, as you can see, they are in parallel, and in parallel, we have the same voltage, right? Which means that whatever voltage we have here at 6 ohms, the same voltage is applied to your R sub A. Can you follow? So, therefore, for us to solve for I sub A is the voltage supplying your 10 ohms or flowing in 10 ohms, 1 ohm, and 7 ohms. So, we simply divide V sub 1 divided by your R sub A. Can you follow? Can you follow, class? So, using here 225 over 37 times your R sub A is 18 ohms. So you'll have 225 over 37 times 18. Okay, you have here 4,050 over 37. And this is already amperes. Okay? There. I'm sorry, class. This is supposedly 225 over 37 over 18. It should not be multiplication. I'm sorry. Kindly correct that. So this is 225 over 37 over your 18 ohms. There. So that is 225 over 37 over 18. There. So that is 25 over 74. 25 over 74 amperes. Okay? Now, class, this is already answer. This is the current flowing in your I sub 10, I sub 1, and I sub 7. Okay? The same current. So, this is already answer also. And this one, the other one answer. Okay? Which is 50. So, this 50 over 37 is the current flowing in 0.38 ohms and 2 ohms. While for I6, we have 75 over 74. And for for 10 ohms, 1 ohm, and 7 ohms, we have here 25 over 74. Okay? Now, how are we going to check if it's correct? How are we going to check it? Okay, let me write this first. 25 over 74 amperes. Okay, so I'm gonna erase this. Let us check, class. But again, it's already the answer, class. I just want to show you, or to let us check it if our values are correct. Okay, now look at this junction here. Okay, as you can see here, so there's an entering current, which is, this is our I sub t, right? And since at this junction, the two currents separated, so which means that this current here, which is I sub 6, will be added to the current here separated, which is I sub A. Okay? So that means, class, that the value of I sub t, which is 50 over 37, should equal to the sum of I sub 6, which is 75 over 74, plus your I sub A, which is 25 over 74. Okay? You have, or it should have the same value. Can you follow? So let's check. Let's check if they will equal. 75 over 74 plus 25 over 74. Okay. What can you see? It's the same, 50 over 37. It's 50. What can we conclude? We can conclude that our values are correct. So once na hindi yan, class, mag-sum up or the same or iba yung sagot mo dito, which means may mali. May mali sa solution mo. Okay, so that's it. That is for the solution for example number 15.